folks, thinking about these questions that involve both momentum and energy, momentum transfers and energy transformations, um, I've sort of come up with the idea that you can use notation perhaps differently than we've always always use notation um, to help yourself keep things a little straight, a little more straight perhaps. And here's what I mean. Remember, one of the first steps in a problem like this, in my opinion, especially if you're not given a nice diagram like this, is to identify what are the instants of interest. All right. So for us, there's kind of instant one, which is just prior to interaction. All right. Instant two, where are you? Instant two, just after interaction has ended. At instant three, when this thing gets to maximum height. All right. And so, for instant one to instant two, that's a two-object interaction. So yeah, that's so 1 to 2, that's a net P initial equals net P final. All right, and so what we might do is say something like generically P1 initial plus P2 initial is P1 final plus P2 final. Well, here's where I think notation can get a little, you can use notation to your advantage. All right, and what I mean by that is, well, this is really our initial and our final. So because there's three instants, might it be more useful to, instead of just saying initial and final, refer to which instance you're talking about? So maybe instead of initial, final, you say 1 and 2, or 2 and 3, or 1 and 3. But then you have ones, and that can get to be a pain. So here's what you might try. What you might try to help yourself keep things straight is you might try and say like, well, why don't I just name this thing, like this is the pellet in one of our questions, so I'll call it P, and this is the bob, so why don't I call it P? And then you could transition this to like, P1, object 1, all right, that's the pellet. And initial is instant 1. All right, so I have the momentum of the pellet at instant 1 plus the momentum of the bob at instant 1 is the same as the, or is equal to the momentum of the pellet at instant 2 plus momentum of the bob at instant 2. Now, okay, so we have P and P. Does that make things more challenging? I don't know. Do you know what momentum is and what an object is? That's the question. So, maybe we can have a little luck there. And then if we said something like, from 2 to 3, well, we know that's a energy transformation, equals ME final. So maybe instead of here initial and final, just so we're sure we're not talking about the same initials and finals that we were up here, I mean, maybe we say like K2 plus UG2 is K3 plus UG3. All right? So, in my mind, identifying objects and identifying instants, as opposed to generically calling them object 1, object 2, instant initial, instant final. Maybe you try to get a little bit more specific. And along with that, maybe you do things like, all right, you write yourself a list. Mass of the pellet is 7 grams. Mass of the bob is 1.5 kilograms. The after the interaction, I guess we call that V pellet at instant 2 is 200 meters per second. All right, so at least then you can really identify what instant things are happening. And to make yourself this list of givens before you just start writing a solution, that can hopefully really help you figure out, well, what number has to go where, all right? And I will tell you what, not at all that I need it to be easier for me, I don't, but I will be able to tell a lot easier, if you make this list, I can just say, oh, this person thought this was the pellet at instant 1, but now it's instant 2. Okay, I see what they did there. All right, so consider writing yourself a list of things you know, right? And not just like writing, oh, they told me 7 grams, so I know that. Well, that doesn't really tell you much unless you identify what that is. All right, so consider a list of givens. Consider talking about, not just generically initial and final, but what instance are you talking about? And then consider talking about which actual objects as opposed to object 1, object 2. Okay? Now, something else I was thinking about with two-dimensional interaction types of things, there's been a lot of question, I've heard the question several times now, how do I know when to do like the trig thing and say, px is p cos theta, or just to leave it as px? All right, well, it boils down to two different scenarios. There, two different scenarios. Here's a two-dimensional interaction in which object 1 and object 2 approach each other like that, and then let's say they stick together. All right, they don't have to, but let's say they do. Now let's put away the fact that we could probably solve this with a Pythagorean theorem approach. But if it's a more complex thing, let's just say there's a problem that looks like this, and we're not going to use a Pythagorean theorem approach. And well, there's one style of question that says, find me either, maybe this is a final system momentum, and maybe we want to find what that is, or maybe it's that we want to go one step further and find the final system velocity. All right, and that means that there's two things you don't know. That means that you don't know, what that number is, and you also don't know what that angle is. So if that's the case, the only way to find both of those things, how big that vector is and what direction it points, is to find P system final X and P system final Y, right? And maybe the V's, right? It's a question. We ask for P or we ask for V. So find the components first. And the reason we find those components is because then we can say, all right, well, if I know what this is and this is, if I know P system final X and P system final Y, okay, I accept that I can now find P system final. And how would I do that? Well, I would use Pythagorean theorem. P sys final squared is P sys final X plus P sys final Y, right? And then this angle theta, we would say, well, the theta is the inverse tangent of P sys final Y over P sys final X. That's an inverse tangent. All right? So the deal is, if the question asks you to find the whole vector, we might write something like, if we do net P initial X is net P final X, then we would say P1 initial X plus P2 initial X is P sys final X. All right? And here, we just want to know what that is, what that part is. It would not help us to write P sys final cosine theta, because these are both, this number and this angle are both things you don't know. So you really can't go this next step and write the x component in terms of the whole vector and the angle. You just want to find what the x component is. Right? So if you're asked to find the whole vector, then don't do the trig thing. Don't do this trig. Just leave it in terms of the components. Now, the other style of question is, let's say that, and there are, again, lots of different ways to do this, but let's say that we're trying to find either P1 initial or P2 initial or V1 initial or one of the, one of these things, here or here, and that means they would have to tell you there'd be a known momentum and a known theta. And if you know what those, what that whole vector is and what that angle is, well, then you can find the parts using the trig thing. So here you might say, all right, net P initial X is net P final X, and let's see, P1 initial X plus P2 initial X is P system final X. Well, guess what? Again, if you know, let's assume that you're told what this is and what that angle is, well, then you'd say, well, here's how I find that. You do P system final times the cosine of the angle, right? Because you know this and you know this. So I think it boils down to, if they tell you enough that you can use trig to find the components, then do it. If they don't tell you enough, because like in this case they're actually asking you to find the whole vector and the angle, then you can't do this. And then you just leave it in terms of the components, and then use the components with Pythagorean theorem and some trig to find the whole answer. Okay? I hope that helps, and I will see you soon.